And begin. Okay, so let's review a little bit. Let's review. And let's say, for example, I have a balanced chemical equation. I have the following balanced chemical equation. I have silver nitrate, and I react it with, let's see here. Let's make it a little bit more challenging. I have two silver nitrates plus CaCl2, calcium chloride, and it gives the following. It gives um, 2 silver chloride, and that's a solid. And we're going to learn very soon how to determine that is a solid. This is aqueous, and the other thing we get is Ca NO3 to calcium nitrate aqueous. Okay, that's a balanced chemical equation, and it's a double replacement reaction. So you should, while you're doing these things, you should understand which type of chemical reaction we're looking at, and also name the chemical compounds. And I say to you the following thing. I say, how many moles, how many moles of AgCl can be produced by reacting 0.5 moles of calcium chloride with excess silver nitrate. How many moles of silver chloride can be produced by reacting calcium chloride with excess silver nitrate? Now remember what excess means. Excess means there's more than enough of that. We're not going to run out. So let's try to have a brain awakening here after our long weekend. If I have excess of that, what does that mean for this? Is it going to run out first? No?
Yeah.
Yeah. I have excess of that. Excess means this is going to hang around even after the other one runs out. Now, in the words of chemistry, we call this the limiting reactant, because this is the excess one. So, just by looking at the number of moles, I'm starting with that. How many moles of that can I make? If I started with 1 mole of that, I can make 2 mole. But read the question. I have point. It'd be one, yeah. And I mean, if you wanted this, you could work through this just sort of in your mind. You could say, well, if I have 0.5 of that, I get 2 for every one. So I would get 2 times 0.5 moles, and that would give me the number of moles of silver chloride. If it helps you, you could certainly write it out like this. Let's see if I can move the old camera down. You could do this trick like we used to, and we're going to continue to. I start out with 0.5 moles of calcium chloride, and I know that I get 2 moles of silver chloride for every 1 mole of calcium chloride. So then, 0.5 times 2, those moles would cancel. I would get 1 mole of silver chloride. So these things, when you're just looking at the relationships between moles, they're very easy. Doesn't matter if you have 2s and 3s or you have these weird coefficients like a 15 or something. It doesn't make a difference as long as you can set it up and solve for the number of moles. So they're pretty easy, and hopefully on your worksheet on mole-to-mole problems, you were able to do quite well with that. I'll have to double check and see if I posted the answers to that or not. I don't remember if I did.
Kind of.
I might have.
I don't think that. I think unless we did a different worksheet and gave us the answers to the back.
Yeah, this one I don't think I actually posted the answers to, so I think I'll go ahead and post it just so you can double check. I know we went over them, but we can double check. Now, what I'd like to do today, though, is I want to go ahead and I want to kind of add two extra steps to this. So instead of saying how many moles of silver chloride, I'm going to say grams. How many grams of silver chloride can be produced by reacting? I'm not going to say moles anymore. I'm going to say 25 grams of calcium chloride with excess silver nitrate. So when we do a problem like this, we have two extra steps because according to the balanced equation, we can only compare numbers of moles to numbers of moles because that's what these coefficients represent. Okay? So we have two extra steps. In order for us to go ahead and say, well, I have 25 grams of calcium chloride. Remember, we're interested in moles. Do you remember how to go from grams to moles? A little bit? A little bit. All right. That's why we're doing this. It's Tuesday morning. We had a long weekend, so let's not panic about this. Let's review. So, first thing, let's change our grams of calcium chloride because that's our given amount. And again, this is our question: how many grams of silver chloride? So first things first, we have 25 grams, and I suggest writing it down just like this and following this pattern because it'll save you. Because sometimes the reactions aren't just simple 1-to-2 ratios or things like that. Now, I'm going to tell you first of all what not to do. Don't ever say this: 25 grams calcium chloride, and I know I get, and somehow you look at this, you say, I know I get 2 silver chloride for every 1 calcium. I've seen this before. And so therefore, I'm going to get 50 grams of silver chloride. That is totally wrong. Totally wrong. Because remember, I said these are molar ratios here, not gram ratios. So I've seen people do that. Please don't do that. Because the first thing we have to do is go from grams of calcium chloride to moles of calcium chloride. So I know that 1 mole of calcium chloride is we got 70 plus 40. I'm just using, just rounding. 70 plus 40 is 110.
Should be calcium chloride, right?
Yeah, CaCl2. I got a calcium. 35. We can call it 111, I guess, because 35.5. But again, if you're going to sit down and do this, take it to the tens place or the hundreds place. But I'm just, like I said, going through it quickly. So if I just put an equal sign there and did the math, I would have the number of moles of calcium chloride. And then bango, I could pop it into that thing. But we can keep on going and carry along and do our calculations in a big line. So then I say, okay, this part here changes grams of calcium chloride to moles of calcium chloride. Now we use the balanced equation to go from the number of moles of calcium chloride to the number of moles of silver chloride. So we're told that we have 2 moles of AgCl, silver chloride, to every 1 mole of calcium chloride. Okay, so then let's see what cancels so far. I should actually write CaCl2 down here. So that cancels with that cancels with that. And if we stop right now, we would figure out how many moles of silver chloride I've got. But again, back in the laboratory, we care about how many grams we're going to make. So we have to go ahead now and change silver chloride to grams of silver chloride. We have to get the molar mass. So 107, it's 107.8 plus 35, 107.8 plus 35, and 142.8. So our moles cancel, and we're left exactly with the unit that we want. So now we plug and chug and do the calculation. So we multiply, of course, everything on the top and then divide by the product of things on the bottom. So 25 divided by 111, and that gives moles times 2 times 142.8. I get 64 grams, 64.3 grams, since I only, let's just call it 64 grams of silver chloride. So that's how you go from grams of your reactant using the balanced equation to figure out how many grams of one of the products we get. Get out of the way so that you can see it, and hopefully you'd be able to do one like that. Matter of fact, let me give you the sheet, and we'll take a minute and try to practice on one of them and then go through it. I'm going to pause this. Okay, so we're looking at this particular mass-to-mass problem. Question number 2. Let's take a look at question number 2. It says, and this is kind of interesting because in the last problem we were talking about, I have a certain number of grams of reactant. How many grams of a product can I make? Well, stoichiometry allows us to compare anything to anything else. So this is saying how many grams of lithium. First of all, let's write the balanced equation. We have 6 lithium solid plus N2 to give 2N, 2Li 3N lithium nitride. This is a solid, and this is a gas. So we have some lithium. We react it with nitrogen gas, and we get lithium nitride. And these are the coefficients. And they say how many grams of lithium. So we want to answer a question about a reactant in this case. How many grams of lithium are required to produce 45 grams of lithium nitride? We don't care about the nitrogen here. We can pretend that we have excess of that. So how many grams of lithium are needed to produce 45 grams of lithium nitride? So 45 grams of lithium nitride, the first thing we have to do is go from grams of lithium nitride to moles. It's always our first step. It's always going to be moles of something. Let's just call it moles of A. You're always going to get something like grams of something. Grams of A convert to moles of A, and then use mole ratio. That'll give you moles of the other thing, and then back to grams of whatever. So that's going to be our pattern time and time again. So lithium nitride. So what's lithium nitride? It's 7, let's call it 6.9 times 3 plus 14.01. So lithium nitride, 1 mole of lithium nitride is going to be, what did I get? 34.7 grams of lithium nitride. So you can see we have a little bit more than 1 mole, which is fine. And now we need to figure out how many grams of lithium I need to make this amount. Well, the molar ratio says I have 6 moles of lithium to every 2 moles of lithium nitride, Li3N. And then we can keep on going, and we could say, well, grams will cancel, the grams will cancel, the moles of lithium nitride will cancel with moles. And so I want to go from moles to grams. And lithium is 6.9 grams lithium to every 1 mole. lithium, so my moles will cancel. And again, just multiply across the top and divide by the product of what's on the bottom. So 45. And I get an answer that we need 26.8 grams of lithium. So in other words, in order for us to make 45 grams of that, we're going to need 26.8 grams of lithium nitride. We could also figure out how many grams of nitrogen we would need. That would be another question. Let me show you that. Like I said, stoichiometry allows us to compare anything. So this first couple of steps here could be the same, because the first step is converting lithium nitride grams to moles of lithium nitride. But now let's say, well, how much nitrogen do I need? Well, first of all, let's write. We needed 26.8 grams of lithium. That's how much we needed. Now let's figure out how much nitrogen we need. Question doesn't ask that, but it's kind of fun to go and do it. So in this case, I know that I need 1 mole of nitrogen for every 2 moles of lithium nitride. And I know that nitrogen is 28 grams per mole. Okay, well, let's see here. We've got 45 divided by 34.7. That'll give me my moles once again. And times 1 divided by 2 and times 28. And I need 18 grams, 18.2 grams, I'll call it, of nitrogen. So in order to make 45 grams of lithium nitride, I would need to use 26.8 grams of lithium and 18.2 grams of nitrogen. Just do me a favor, if someone has a calculator, add those two numbers up. Or you don't even need a calculator. Just add them up. 45 grams. Coincidence? Nope. Law of conservation of mass. If I want to make 45 grams of that, well then the reactants have to add up to 45 grams. So, all right, guys. Well, I'm gonna let you work on some problems, and then we'll go over them. So enjoy and watch the video if you need to.